Hi students, welcome to our channel SJC E-Learn. Today we are going to discuss about meter bridge. What is meter bridge? Principle of meter bridge, working of meter bridge, and the result of meter bridge. Basically, the meter bridge is a device which is a very sensitive device, and its principle is based on the principle of Wheatstone bridge, which we have already learned. And it is a very sensitive device. It is sensitive more than that of post office box, which is used for measuring the unknown resistance of the given wire. In the same way, having principle of Wheatstone bridge, meter bridge is also used for measuring the unknown resistance of the given wire. Here we have an unknown resistance S, which has been connected in between point D and point C. Now, basically, first of all, I want to tell you the design part of the meter bridge. Why it is called a meter bridge? Because in this device we use a wire of 1 meter, that is wire AC. The length of this wire is 1 meter, and in other way you can say that 1 meter is 100 centimeter. The length of the wire AC is 100 centimeter. And now this wire is made up of magnum or constantan, having uniform cross sectional area. Here we have a resistance box in between the gap C and A, unknown resistance S in between the gap C and D. A 1 meter wire of magnum or constantan, a cell or battery. You may use battery eliminator in the lab or rheostat for varying the current in the circuit, and a key for open and closed circuit measurement. Now, this device is totally based on the principle of Wheatstone bridge, and we have already learned about the principle of Wheatstone bridge, that the ratio of the arms, like arms R and arms P here, that is pointed by the length AB, and the ratio of S and Q. And now we are just want to find out the value of unknown resistance S. What we have to do, we have to just apply the principle of Wheatstone bridge in this device, and we have to find out the balance point, that is null point, by sliding or touching the jockey on the wire AC. When there is no current in the galvanometer, when there is no current in the galvanometer, at this point the potential of point B and potential of point D will be equal. Due to same potential, there will be no current in the galvanometer, and we have used a shunt wire for protection of galvanometer in case while measuring the length, sometimes it may have that you will get a maximum current in the galvanometer. So protecting the galvanometer, we use a sand wire. And now we will write the equation according to Wheatstone-Bridge. P upon Q is equals to R upon S, the respective resistance of the arms of a quadrilateral made in this way in Wheatstone-Bridge, and the diagonal is connected by a galvanometer which is having no deflection. So in this way, just write down the value of resistance of P, Q, R and S. So the resistance of P, here we can write down resistance of P, that is Rp, and it can be written by rho L upon A is the area of cross section. Let's suppose this is capital, and the length of wire AB is L. In the same way, you can write down the resistance of length BC, that is resistance of Q, that is rho. Length is, this is L, subtract it, and you will get the length of BC is 100 minus L upon area of cross section, that is A. So this is equation number 1, equation number 2, and finally the resistance of resistance box is capital R, and the resistance of this wire, which is unknown resistance, that is S. Just write down all the values in the equation, and P, this is rho L upon A, divided by resistance of Q, that is rho 100 minus L upon A, is equals to R upon S, that is R and S. So just calculate it. After solving, you will get L upon 1, that is 100 minus L upon 1. To solve it, you will get L upon 100 minus L, that is R upon S. From the equation, you will get a final result. S is equals to R 100 minus L upon L. This will be the value of unknown resistance. By measuring the value of L and you know about the value of R, which is the value of resistance box, the plug pin, you know the value of resistance R, and also know the value of L in centimeter. Just put all these values and you will get the value of S. So in this topic you have learned about meter bridge. It is called meter bridge because we use 1 meter length of a Magnum or Constantan wire, and the principle of this meter bridge is based on Wheatstone-Bridge, and applying the equation of Wheatstone-Bridge, you will just find out the value of unknown resistance whose value is to be measured by you. Meter bridge is a very important instrument. There is a practical which is based on the meter bridge. The calculation will be done in the same way. You have to just calculate the value of length L, that is null point, which can be calculated by pointing out the galvanometer. When you will get zero deflection, that is null point, then at this point the value of L can be calculated, and after using the value of L, you will just find out the value of unknown resistance as by using the formula. So student, I think you have learned about the meter bridge. In the next class we will discuss more apparatus regarding this chapter. Till then, stay connected with us. Thank you.